Welcome to the Snowflake Technical Series. My name is Anthony Zhang, and I'm a Snowflake Data Engineer here at KCM Solutions. So today's topic is going to be on virtual warehouses. We'll give a quick overview of virtual warehouses, a small demo, and then we'll talk about scaling up versus scaling out as use cases for virtual warehouses. So virtual warehouses in Snowflake, as you can see from this architecture diagram, is responsible for all the query processing. So what this means that the virtual warehouses are responsible for processing all the SQL select statements and DML operations, such as deleting, inserting, updating rows in a table, or creating a table. Also, these warehouses already come with all the required resources, such as CPU, memory, and the temporary storage, and you just have to choose the size and what kind of clusters you want in your warehouse. And as you can see down here, sizes are done based on t-shirt sizes, with extra small being the smallest and 4x large. As you go up a t-shirt size, you get double the amount of servers as the previous. So here from the small, we get extra small, we get 1. If we go to small, we get 2 servers. We size up again, we get 4 servers. And this is called scaling up, which is where we get greater compute resources for more complex queries. So now we'll move on to our demo. So I have this database called CityBike, and I'm trying to load the trips data into Snowflake. So as you can see right now, we'll begin with using an extra small warehouse. So first, I'll create the table. Created the table. As you can see, these are all the files I want to load. So using my extra small warehouse with 1 server cluster, I will run this and we'll load the data. So the data has just finished loading, and as you can see, it takes around 1 minute and 15 seconds using the extra small warehouse to load around 61.5 million rows here. So what we're going to do is we're going to drop this, and then we're going to see if we could do it with the large warehouse. So remember, this has 8 server clusters compared to the 1 in the extra small. And to change it, we simply just execute a SQL statement here, or we can go to the Warehouses tab, Configure, and change the warehouse size here. So we will go back to our worksheet. We'll run this query, and you can resize the warehouse whenever you'd like. All previous currently running queries will just run on the extra small, and then any new queries will run on our large database. So let's load the data now with the large. As you can see here, we have now a large warehouse. Let's load the data now. So with a large database, we load all these records in only 12.5 seconds compared to the 1 minute 15 seconds using the extra small warehouse. Which means that we almost got a minute increase in only this small sample set. Imagine we had multi-terabyte tables. You can see the improvements in these extra bigger warehouses. So what we just did here is an example of scaling up as you increase the warehouse size from extra small to large. As you can see here from this diagram, the blue represents the load time. Blue line. As you can see from extra small to large, it increases almost linearly. And after large, you don't really get as greater improvements. So in most cases, large would be the best. As you can see, the cost when you start getting to 2XL increases drastically, but most cases, large would be sufficient enough for all your needs. But this is mostly dependent on, let's say you're a data science team and you have complex queries or queries that require a lot of resources. It's best to scale up, such as having a large warehouse so your queries could run faster. In this case, loading 1 billion records. As you see, large, you get the best increase linearly from extra small, but later on, as you move on to greater warehouses, you see it gets more marginal gains. And then another example of increasing warehouse size is scaling out for multi-clustering. Now, this is best used for concurrency issues, such as, let's say in the morning, you have a bunch of BI users that need to refresh their dashboards and everyone's running their queries. This would be best for them. So you'll see in the top row, this is a medium 1 cluster, so 1 server, extra large 1 server, medium 1 to 4 clusters. So you can see a medium here has around 4 clusters, extra large 16, and a multi-cluster will vary because it's multi-cluster. It will scale up automatically. Snowflake will scale it up based on the concurrency. So in the second row, you can see that these are the outputs that it's putting out, but it's not matching the amount of queries and requests that are happening. As you can see here with the multi-cluster, right here is the peak, so we will get significantly the greatest output here. While in these two, it's mostly the same because the warehouses cannot handle all the concurrency. Even though this is extra large, it does not have the multi-clusters as a medium has. And as you can see here, the response time with the medium 1 cluster, during your peak hours, it takes the longest time to get your responses. And here in the multi-cluster, everything is pretty much low response time. And as you can see here, extra large warehouse costs extra, as it has the most server clusters, but here in medium, with multi-cluster for concurrency, as it can scale up and down, will give you the best value, as it will scale up only when it needs the resources and scale down. Well, these two will always use 16 servers, but as you can see in the extra large, it does not really solve the concurrency issues. Scaling up will help you with complex and more difficult queries. So as you can see here, with a small warehouse, this will show you the time, and it's all doing the same amount of work. And this is a medium warehouse. You see you split the runtime almost in half, and this is a multi-cluster, which does it just as quick, and as you can see, much faster. But in this case, it doesn't matter which warehouse size you choose, because in the end, they all cost the same amount. Here, because you pay for the compute and the pay-as-you-go structure, the small uses the least amount but takes the longest. And then the multi-cluster uses more resources but takes the shortest, but it still pays all the same. So it is in your best interest to take a look at what your needs are and choose a warehouse appropriately. So the best features of a virtual warehouse is you pay only for what you use. So no matter the workload, no matter the warehouse size, multi-cluster, it doesn't matter what you choose at the end, it will cost all the same. You only pay for what you use, the compute resources, and on a per second basis. You can choose it based on your organization's needs. Additionally, performance is also a great issue. As you can see, we can scale up to deal with more complex queries, for example, in those data science teams. We can scale out with multi-cluster for those concurrency issues for people with such as business intelligence dashboards. And last but not least, as you can see with setting up a virtual warehouse, there's almost near zero maintenance. As soon as you set up the warehouse, you just choose the size, you begin using the warehouse immediately. So thank you for listening to this technical series. For more information, you can email info@kcmsolutions.com or visit our website at www.kcm-solutions.com.